Hello everyone. Today we are going to discuss the sixth problem of AtCoderBeginner Contest 340, which is f minus s equals to 1. So what is the problem? So we are given two integers x comma y, both are non-zero, and at least one of x and y are not zero. Now we have to find a pair of integers a comma b that satisfies all the following conditions. So a comma b lies between minus 10 to the power 18 to 10 to the power 18, and this is the important condition. The area of the triangle from 0 comma 0 xy ab on the xy plane is 1. So we have to find any such xy. Okay. uh, so if there is no such xy, we have to print minus 1. Okay. Now let's take some example. So if the example given is 3 comma 5, answer is 1 comma 1. So that means that area of the triangle with vertices of at point 0 comma 0, 3 comma 5 and 1 comma 1 is 1. Okay, so you can take 3 points in the coordinate plane and take the area of the triangle formed by these 3 points, then the area will be 1. Now for solving this problem, the most important thing is to find the formula how we can find the area of a triangle with 3 points in the coordinate plane. Okay, so let's take the look at the formula. So the formula is nothing but half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So let's copy this formula. Let me write here. So this is the formula, right? Okay. Now what are our values? So what are our values? Now our x1 y1 are nothing but 0 0. So x1 y1 are 0 0. And what is x2 y2? X2 y2 is nothing but our a and b, and x3 y3 is nothing but our x3 y3 is nothing but our x and y. So let's write the formula with these terms. So let me write it. The formula will be nothing but half of this is mod. So half of mod x1 into y2 minus y3. Now x1 is 0, so this first term is getting cancelled out. So let's write in the second term. So x2 is what? X2 is a, and what is y3? Y3 is nothing but our y, so ay, and y1 is 0, so I am neglecting that term. Now what is x3? X3 is nothing but our x, and what is our y2? Y2 is nothing but our b. So as x3, y1 is 0, so y0 minus b, this will be minus then. So ey minus bx, the area of the triangle is half of ey minus bx. Now what is the formula? The formula is this term, half of ey minus bx equals to 1. That means ey minus bx should be equals to 2. Ey minus bx should be equals to 2, or you can take the mod. So mod of ey minus bx equals to 2. Okay. Now we have to find the value of x and y. So now if something is negative and if we multiply it by minus 1, so let's say our answer is x comma y. Now we multiply it by minus 1, then our answer will become minus x and minus y. So we can neglect the mod term here. So instead we can write ay minus bx equals to 2. Okay. So we have to find any such values of x and y such that ay minus bx equals to 2. Now how we can solve this problem? For solving this type of problems, this is called as linear Diophantine equation, where the equation is the form of ax plus by equals to c. I will provide the link of the CP algorithm in the description box. You can look that out. So this is the if any formula is in such form, ax plus by equals to c, if the solution exists, we can find it using extended Euclidean algorithm. So I hope you all know about Euclidean algorithms. So what is Euclidean algorithm? Euclidean algorithm of finding GCD. So the algorithm says us that GCD of a comma b is nothing but GCD of b comma a modulo b. Okay. So this is the Euclidean algorithm, and the time complexity of this algorithm is nothing but order of log of max of a comma b. This is the Euclidean algorithm. And what is the extended Euclidean algorithm? The extended Euclidean algorithm says that he can find the algorithm can find ax plus by equals to z, any solution of ax plus by equal to g, where g is let me write here, where g is nothing but gcd of a comma b. Okay, now we can find ax plus solution of ax plus by equals to z with this equation, g equals to with the extended Euclidean algorithm. Now you can look at that let's say this is the solution of ax plus by equals to g. We can so get the values of xg and yg using our extended Euclidean algorithm. Now our x0, the original value of x will be nothing but xg into c by g, and y0, the value of y0 will be nothing but yg into c by g. Okay, so the problem becomes quite straightforward to us. Now what are the values of x and y? Now we are trying to find the solution of ey minus bx equals to 2. Now the extended Euclidean algorithm will give us the solution of ey minus bx equals to gcd of a comma minus b, right? Because ax plus by equals to 0, and so extended Euclidean algorithm will give us the solution of ay minus bx equals to gcd of a minus b, and after that we can multiply it by c by g, or 2 by g you can say, to get the correct answer. Now when the answer will be impossible? So the answer will be impossible when the value of c, we can find the solution of x plus by equals to c, right? X plus by equals to c. Now if c modulo g is not equals to 0, then the answer will be impossible. Now what is the value of c? The value of c is in our equation is nothing but 2. So if 2 modulo g is not equals to 0, then our answer will be -1. Answer equals to -1. Otherwise we will find answer. Okay, find answer with what are our parameters? Our parameters will be nothing but a comma minus b. Okay, so that's the overall algorithm of our problem. So let's look at the code. I will try to explain the extended Euclidean part also. So here is the extended Euclidean algorithm part. Now here I am taking the input a comma b. Now if 2 modulo gcd of a comma b is not 0, we are printing -1. Otherwise we are finding any solution of I have just copied the entire code from here, this part, and xy will give us the value of our x plus, let's say our ax plus by equals to g. Ax plus by equals to g, we will get the let's say ax plus by equals to c, then we will get the value of x comma y with the following equation. So let's say here we are passing a b c x y and g. Here you can see that I am passing a minus b to x y and g. So g is the gcd of a comma b. Okay, sorry, g is not the gcd of a comma b. G is let me look at the code. Here is the code. So after the solution, g will give us the gcd of a comma b to us. So so I have initialized the variables x comma y comma g, and I am passing that to our find any solution. Okay, so the algorithm, the values are a minus b comma 2. So we will get the solution of ax ax minus by equals to c equals to 2. Okay, now one important part here is that ax minus by equals to 2. One important part here is that we have to print x and y, and here we are finding y and x. So after that we have to print y comma x. We can't print x comma y because our equation is nothing but ey minus bx equals to 2. Okay, now let's look at the extended Euclidean algorithm that is mentioned here. Now let me explain the extended Euclidean algorithm, or extended Euclidean. Let me write here. So our equation is ax plus by equals to g, right? X plus by equals to g. Now our Euclidean algorithm says that a gcd of a comma b is gcd of b comma a modulo b. So what is A modulo B? A modulo B is nothing but our B minus, if we take the float term of A by B into B. Okay, I hope you get it. Why? What is A modulo B? If we explain it in simple multiply and division or addition terms. Now Ax plus By go to G. Now the GCD is same for if GCD of A comma B is G, then the GCD of B comma A modulo B is also G. So we can replace A and B with B and A modulo B. So let me write at Bx1 plus A modulo B into y1 equals to G. Now if we replace the value of A modulo B here, then what we will get? We will get Bx1 plus B minus A by B into B y1 equals to G. Now if we separate out the terms of A and B, we'll get I think this will be nothing but A minus. This will be A minus, not B minus. So this will be, this the value will be A. Now we'll get AY1 plus B, let's take B common, then this will be x1 minus this thing A by B, floor of A by B into y1 equals to G. Now you can see that the value of x in the first equation, let's call it as the first equation, the value of now this is the second equation. Now you can see the this is common and this is common, so the value of x is changing to what? The value of x is changing to y1, and the value of y is changing to what? The value of y is changing to our x1 minus a modulo b into y1. So how we can represent our x and y with the previous x1 and y1 in the Euclidean algorithm. Now let's look at the code. Here you can see that we are calling the GCD function. GCD function will give us the GCD value, and the value of x0 and y0 will get modified because we are passing the reference. Okay, the value of x0 and y0 will get modified. Now we are taking x1 and y1, so let's call it x0 y0. Now x1 and y1, we are calling the GCD function again, GCD of b comma a modulo b, x1 and y1. Now after we have computed x1 and y1, the value of x0 will become what? Y1, and y0 will become what? x1 minus a by b into y1. And if the value of b is 0, this condition is similar for our normal Euclidean algorithm also. If b equals to 0, then x will be 1 and y will be 0 and the GCD will be a. Okay, because b is 0 and a will be some value of GCD. So here the thing also handled that if c modulo g is not 0, then we are returning false, so no solution will exist. Else we are multiplying it with c by g, x0 multiplying it by c by g, and this is also handled. If a less than 0 will multiply. This part I don't think is needed, or I'm not sure. You can look at that. So I hope you get my solution. I will provide all the things, all the links, extended Euclidean algorithm, solution of linear differential equation, and how we can find the area of a triangle, and also the link of my code in the description box. You can look at that. If you find this video helpful, please like the video and subscribe to my channel. Thank you.